Motion of a skydiver, and we have here two terminal velocity. Try to understand it. In y-axis we have vertical axis. That one is showing us velocity of the parachutist, and here in the x-axis we have time. So with time, at first the parachutists don't open the parachute, okay, just falling,
Yes, sir.
and we have constant acceleration. You see, we have here constant acceleration, and after some time it decelerates, not decelerates, its acceleration decreases and resultant velocity is 0. Then it comes at constant velocity, right, steady velocity. Parachute did not open yet that time, and one stage here after 42 seconds, you see it's written here, parachute opens at t equals 42 seconds, jumps at time t equals 0 seconds, and here terminal velocity 1, that is 50 meter per second, okay, here terminal velocity 1, 50 meter per second. Then when the parachute opens, then suddenly lots of, parachute is big, right, big thing, so suddenly lots of air resistance is working together on the parachutist, and deceleration is huge, right. You see within 50 seconds the speed reaches very low, right. Hello, Navid. Hello,
Yes,
Navid.
sir. Yes, sir. Yes, sir.
Yeah. So it's coming here, and uh, again we have air resistance too much, and the weight of the parachutist and air resistance are balanced, and we
Assalamualaikum,
have
sir.
here steady velocity. Okay, steady means constant velocity, and here we are having terminal velocity 2, that is 8 meter per second. Okay, it is 8 meter per second, and after that the parachutist reaches to ground, right.
Yes, sir.
See here lands, that means he touches the ground and he lands at 70 seconds. So when it touches the ground, that means the speed becomes 0, right, velocity becomes 0, stationary position. So Farhan, welcome back.
Yes, sir. Thank you, sir.
Welcome back.
How's your
So
health?
motion of a skydiver, right, motion of a skydiver, we have velocity in the y-axis, time in the x-axis, and we have the parachutist falling down with constant acceleration at the beginning. Parachute did not open here, just jumps at t equals 0 second, then constant acceleration. The acceleration decreases and reaches to terminal velocity. It is steady velocity in terminal velocity. So terminal velocity 1, it is 50 meter per second. We have here time also, you see, and the time 42 seconds. The skydiver opens the parachute, and when it opens the parachute, the air resistance working a lot, right.
Yes, sir.
Okay,
স্যার
so
খেয়াল আছে আমার আপনার এই বিষয়টা নিয়ে অনেকদিন হয়েছে, আলোচনা হয়েছে।
yes, we discussed a lot. Now we are getting here actually two terminal velocity here together. This graph is, that's why, exceptional graph. So We have here terminal velocity 1 when the parachute is not opened yet. And we
Yes,
have
sir.
here terminal velocity 2 when opens the parachute, the air resistance is working a lot. That time again we are having the terminal velocity, that is 8 meter per second. Okay, that's why I wrote here terminal velocity 2, terminal velocity 1. And when it lands at 70 seconds, the speed is 0. So please label and draw it nicely, huh? All of you.
Okay, sir.
Sir.
Everything you label, huh? So that it is a very good notes for you till A level exams. And you can also explain to anyone this one, yeah, nicely with confidence. Let me know once you are done with this drawing.
So almost done.
Yeah, finish it quickly.
স্যার আমরা কি নোটস গুলি মানে বের করার কোনো উপায় আছে না আপনি না থাকলে আসলে বের করা যাবে না?
Actually, you can write this note or you can take this note, but explanation is required.
No,
Why?
that's a must.
Yeah, that's why if I give you only, that's not giving you that much benefit. And while it happens, when you are drawing without the explanation, your
Yes, sir.
taking notes is sometimes is wrong, right? It's not
Yes, sir.
to the point accurate. That's why nowadays I'm not allowing you to take the notes earlier, because I found the some evidence that student, they they are not able to take the notes properly, only notes, and they don't understand many things, right? So
Yes,
it's
sir.
only like robot, you are writing, you are not understanding, it's useless. That is also another boring thing, wastage of time. Slowly you learn, and slowly you take, that is better for you.
Okay.
Now you got the explanation, you can draw correctly, right? Where it is this acceleration decreases, you can draw. Where it is constant speed, then decelerates, you can draw, level everything. If you write the notes alone, maybe you will miss this, you will miss other points, because that time you will not see carefully all these things. You are done, Farhan?
Done, sir.
Yes, sir.
Okay, so we are done with the kinematics, one-dimensional motion, that is linear motion. That one you also got in O level, but the one we are going to discuss now, that is two-dimensional motion. It's completely new for you. It's projectile motion, projectile motion or two-dimensional motion. Can you read, Farhan, what's written here?
Certainly, sir. Previously, we discussed about motion along straight line, that is one-dimensional motion. We will now think about the motion of particles moving in paths in two dimensions. This is also known as projectile motion. At first, Galileo gave an accurate analysis on this motion by splitting the motion up in, into its vertical and horizontal components. For this, we need to recall ideas of vectors in topic 1.
Oh, you got this in topic 1, that we have coplanar vectors for a single vector A we have two dimensions. One is horizontal component, another one is vertical component, right?
Yes, sir.
Horizontal component is a cos theta and vertical component is a sin theta. So this one we know in topic 1, and this is the basic. Yeah, for the
Yes,
projectile
sir.
motion, this is the basic. That's why we brought this idea here. So please write from here, projectile motion. Whatever is written, everything you read. Right.
স্যার নাভিদ আর আসবে না, জয়েন করবে না?
Navid is here.
সরি, আসান.
Asan, no, he will enjoy today. He already told us, right?
Yes, sir.
He will come tomorrow. He will come and see the video. That's the benefit of working together, right? If
Yes, sir.
you have anything emergency, if you are missing the class, then you can make up it, right, by watching this video.
Yes, sir. স্যার কতক্ষণ আমরা ক্লাসটা কন্টিনিউ করবো স্যার?
We will continue till 10:30.
ওকে স্যার।
10:30 we will continue. If you want, I can continue 10 minutes more, 10:40.
না স্যার, আমার 10:30 তে যে আক্তার স্যার।
Okay, thank you. So, Akhtar sir is still free or he has some jobs?
He has some students, no jobs.
Okay. So you are also private candidate. You can take a slot during the daytime.
Who, sir?
Is it not possible?
Yes, sir, we can.
No, from Akhtar sir. I'm saying Farhan.
Watch this.
না না স্যার, মানে দিনের স্লটই থাকে, আজকে আবার ওনার ওই বাসা পাল্টাচ্ছে।
Oh, I see. This is exceptional slot, right? Because
yes sir, exception. এত রাতে বসি না কোনো সময়।
late night, because I know
yes,
sir is always getting early and offering fajr prayers. Okay. So
স্যার ওনার সিচুয়েশনটা এখন হয়েছে কি, চাকরি বাকরি নাই তো, আসলে জীবন দিয়ে দিচ্ছে যে কজন আছে তাদের কাছে।
He has to go to bed early, right? So how many students he has now?
5-6.
5-6 students. Okay, that's not small number. That's good number for him, right?
Yes, sir.
So, are you done this part, Navid?
No, sir. No, sir.
For
Writing.
me, you can do in the daytime only after Fajr. Okay, from
Yes,
7 to 8:30, it is possible for you if you want to do.
So I'm also free. So I don't sleep after Fajr.
You don't sleep after Fajr. And I also see Farhan is also early lever, right? He's
Yes,
getting
sir, I'm
early.
early riser.
So after Fajr, from 7 o'clock, if you want, I can take class that time.
Yes, sir, certainly. আসানরা জিজ্ঞেস করে দেখেন, ও যদি ফ্রি থাকে তাহলে নিলাম, মানে করলাম ক্লাস।
Sir.
That time your brain will work more, right?
স্যার আমি গিটার শিখি, বুঝছেন, গিটার শিখতে যাই সকাল 6টায়।
Oh,
মানে
that's really good.
না আমি ক্লাসের কথা বলতেছি না, আমি বলতেছি আমি টাইম ওইভাবে ম্যানেজ করে নেই।
No, I'm saying that you are going early in the morning for learning guitar. That's awesome. Yeah.
দিনটা মেইনলি এখন লেখাপড়ার জন্য রাখি।
Okay, very good. So, are you done?
One second, sir.
So done.
Okay.
Done, sir.
Now, projectile motion, like you are standing on your roof, right, Farhan?
Yes, sir. Yes, sir.
And you are throwing one stone straight horizontally. If
Okay.
someone is standing on the higher place and throwing something, that time we are getting this shape of this projectile. You see projectile motion when the object
When the
is shown
object is thrown in a horizontal
horizontal
direction.
direction. First you understand, don't write anything now. Look here, when the object you are throwing is straight, the
Yes,
object
sir.
is going with the at the beginning is going with the velocity you are throwing it, but there is also one force acting downwards, that is gravitational force, right?
Yes, sir.
Isn't it? So you are throwing with one force and another force is working downwards. That's why this object will have two components of velocity. One is working downwards, that is Vy, and another
Mm.
one is Vx. Okay. At the
Yes,
beginning,
sir.
we have Ux, Uy, and after time t, it is Vx, Vy. Okay.
Yes,
Is
sir.
it clear? And after, the initial velocity always we represent with u, right? So at the
Yes, sir.
beginning your initial velocity is u, that has two components, one is ux, another one is uy, and after time t we have vx, vy. Okay. And
Yes, sir.
we have here the the horizontal displacement of the particle after time t, that is half gt square. That one we will
Okay.
discuss. We have step by step. So what is in the graph? I am just giving you the explanation now. What is written here? Can you please read, Farhan?
For example, think about a particle sent off in a horizontal direction and subject to a vertical gravitational force, wave.
Hmm. Yeah. Then read it.
At time t equals to 0, ux equals to ux. A equals to g through the motion in y direction. Uy equals to 0. Later on, it increases under uniform acceleration g. At
Okay.
time
Till
t
here.
equals
Hold
to
on.
t.
Hold on here. Till here, you hold on and try to understand it. At time t equals 0, you are throwing it, right? So
Yes, sir.
at the beginning, we wrote here ux equals ux. That means velocity has two components, right? Initial velocity
Yes.
has two components. One is ux, another one is uy. And at the beginning, as you are throwing, your throwing is horizontal, right? From the roof,
Yes,
you
sir.
are throwing horizontally. So the horizontal component is the one the one you are applying. That one is horizontal component, and that is ux equals ux. Now that time we have acceleration that is working downwards, right? uh,
Yes, sir.
that is acceleration due to gravity, because the object will fall down, right, due to the gravity. So
Okay.
we are taking that one as acceleration, a equals g, and uy, as at the beginning we don't have the vertical component started working. Later on it will work, right? At time t equals 0, we don't have any vertical component. That's why uy
Okay.
equals 0. Later on it increases under uniform acceleration g. Okay, now Navid,
Okay.
you read this. At time.
At time t is equal to t, Vx is equal to ux. The horizontal component ux always remains constant. Vy is equal to uy plus at is equal to 0 plus gt. Vy is equal to gt. S is equal to ut plus half at square. Then x plus
Okay, okay.
uxt.
Okay, hold on here. Till here you understand, then we'll go to next step. Now look here. At time, you have to understand it and you have to remember it. At time t equals t, that means after, for example, it may be 5 seconds or 10 seconds or 20 seconds. That one we are saying at time t equals t. So that time your velocity will be v, right?
Yes, sir.
Velocity will be v. So
Yes.
v has two components. One is vx, another one is vy. So
Okay.
what is vx? We are saying vx will be still ux. Why? The the horizontal component, the way you thrown it, that one will be always constant. The horizontal component ux always remains constant for the entire journey. Okay, because
Okay, sir.
horizontal one is not affected. Only the vertical one is affected by the gravity, because we know gravity is working downwards, right? Isn't it?
Yes, sir.
Yes, sir.
So your increasing or decreasing will be in the vertical component. Is it clear to you?
Yes, sir.
Yes, sir.
Okay. If you are throwing upwards, then it will decrease. If you are throwing downwards, then it is increasing, right? So here our object is falling downwards. That's why our vertical component will increase. Okay. So we have previously the vertical component here uy was 0, but now vy it will increase. It has some value. What will be the value we calculate here? We had uy 0, right?
Yes, sir.
The uy means initial velocity component, vertical component uy is 0. Then we have plus 80. A is for, as it is vertical component, we have here g, right? Vertical,
Yes, sir.
and
Yes, sir.
acceleration is g, and vy equals gt. Okay, is it clear to you how we got vy equals gt?
Yes, sir.
Okay, now s equals ut plus half at square. So this one is coming x.
Yes, sir.
S equals ut plus half at square. That is our vertical component of displacement is x. That means vertically it's going some distance, isn't it? See in the diagram. You see, if you look at the diagram, you see vertically is going some distance, isn't it? This way,
Yes, sir.
and also is going horizontally some distance. So distance or displacement, it has also two components. One is vertical component, this is y,
Mhm.
and another one is horizontal component, that is x. Ux into t, right? How ux into t coming? Because horizontally this equation we are applying for both horizontal and vertical component. For horizontal component we don't have any g, right? Isn't
Yes,
it?
sir.
So g
Yes.
is here 0, acceleration is 0, then it's coming uxt. For vertical component we have uy was 0, isn't it? Because the equation
Yes,
is
sir.
coming uyt plus half at square. So in place of uy we have 0, that's why this part is 0. Then we have here half at square, that means half gt square. That's why in the diagram you saw before that the vertical component of the displacement is half gt square, and here you see a horizontal component is x equals uxt. So Farhan, if you give uh, 3 or 4 minutes now, then you can finish it, right? Because you understood it completely. So at least
Mhm.
horizontal component we are done. Do it, huh?
Okay.
Okay,
Yes, sir.
do it please quickly. Then our class will be over.
স্যার আপনি আমাকে এই জিনিসটা একটু মেইল করে দিতে পারবেন স্যার?
Sure, I can mail you, no problem.
তাহলে স্যার আমি তখন একটু কপি করে নিই।
Okay, no problem.
ওকে স্যার, আল্লাহ হাফেজ স্যার।
Okay, I love it. Then
নাবিদ,
Navid, you
বাই
take
বাই।
it, huh? Navid, you take it, please.
নাবিদ সাবধানে যাও বাড়ি।
Sir, will I take the test now?
No. You take it. This notes now. I'm
Okay, sir.
নাবিদ
saying about
সাবধানে বাড়ি যাও।
yeah, Navid.
আল্লাহ হাফেজ স্যার।
You take this note now.
বাই বাই স্যার। আসসালামু আলাইকুম।
Bye. Allah Hafiz. Thank you, Farhan.
ফর হোয়াট?
Thank you for joining, taking part in
থ্যাংক
class.
ইউ স্যার ফর টেকিং দি ক্লাস।
Yeah.
আল্লাহ হাফেজ স্যার।
Allah Hafiz. Best of yeah. Navid,
Yes, sir.
take this note. Projectile motion
Yes, sir.
when
I'm
the
taking.
object is thrown in horizontal direction. Let us finish the class. Finish this note first, then we'll discuss. If you want to take now the test, you'll take. Then if you want to take later, you can take later.
Sir, I'll take later. Actually.
Okay.
Sir, done.
Done. Okay. Then next, this part.
Sir, then.
Yeah.
Sir, then?
Hmm. Here you are done, right? Y equals half dt square.
Yes, sir.
So today this much. In our next
Okay, sir.
class, okay, this one also you write. You see, find the velocity of the particle at time t. The two components Vx and Vy must be added vectorially. V equals square root. This one you know, right?
Yes, sir. Sir, done.
So in our next class, we will discuss this part.
Okay, sir.
Projectile motion when the object is thrown at an angle theta with horizontal. So we can
Okay,
throw
sir.
the projectile in two ways. From a higher place, we can throw it horizontally, or from the ground, we can throw upwards, right? At an angle.
Yes, sir.
So it will be discussed in next class. Thank you so much. So what about
Okay,
test?
sir.
What your plan about test? So when you'll return back, that time you'll do,
Okay, sir.
or you'll do before going. What?
Sir, after I return,
Okay, that's better for you, right? Okay,
yes,
tell
sir.
me when you are returning. You inform me.
Okay, sir.
Thank you so much.
Sir, assalamu alaikum.
Walaikum salam.